Hey everybody, today we're looking at division of polynomials. So when we talk about division, it's, well, the opposite of multiplication. So instead of multiplying two things together, we're trying to break something down to get some different pieces. So how we're going to do this here with expressions is, first of all, we're going to write everything out in standard form, so from biggest to smallest. So we'd make sure we have our x to the fourths, and then our x to the thirds, and x squareds, and then x's, and then numbers. So everything needs to have that placeholder, all right? And now we're going to divide by the largest term only. And the reason I say that is it's very similar to if I gave you a regular division problem. This one just happens to be large. But if you guys are going to set this up, all right? So our first number we put inside the box, and then we divide by the second. All right, so how we would set this up with long division is we'd go, all right, 22 goes into 35 how many times? Or if you guys remember when we started doing division way back in what, 4th or 5th grade, we would just look at our tens place, right, and say 20 goes into 35 how many times? We'd put the 1 here, right? 1, and then we would multiply this by everything in front. So 1 times 2 is 2. 1 times 20 would be 40, right? 1 times 2 is 2, my bad. All right, we'd subtract those, so we'd get 13, and then, well, we'd bring down our next term. Then we'd say, all right, well, let's see, 20 is going to go into 137, looks like probably about 6 times. So 6 times 2 would be 12, carry the 1. 6 times 2 is 12, carry the 1. And then we would keep subtracting until we are done. And the reason I bring this up is our steps for polynomials are exactly the same. We're going to look at whatever our biggest term is out here and see, well, what does it go into? And then whatever number we put up top, we multiply it by everything out in front. All right, so just to recap on what we've done so far, we have talked about factoring. And the big difference between when we can factor and when we are dividing is if we have an addition or subtraction on the bottom. So up until this point, when we've been simplifying polynomials or simplifying fractions, expressions, we have not had a plus or minus on the bottom. That changes the game. So when we have something like this, this is where our division is going to come into play. So let's set up a couple examples. All right. So we have x to the third minus 2x, or excuse me, x to the third minus x squared minus 2x plus 8 divided by x plus 2. So we're going to set this up for long division just like we did on our number example. So we'd start with, we have our x to the thirds. Then next is our x squareds. Then our regular x's. And then our plain numbers. So we had everything accounted for from top to bottom, so we don't need any zeros or placeholders. And then we're dividing by x plus 2. So once again, we're going to see, all right, this first term goes into this first term how many times? Or in other words, this times what gives us this? Well, x times x squared would give us x to the third. Again, the process is the same. The numbers are just a little bit different. X squared times x would be x to the third, right? And we multiply by everything out in front. So 2 times x squared would be 2x squared. Just like regular division, we subtract. So our x cubes would go away. Minus x minus 2 would be minus 3x squared. Just like regular division, let's bring our next term down. And now our process repeats. X times what gives us minus 3x squared, be minus 3x. Once again, whenever we put up top, we multiply by everything in front. So this would be minus 3x squared. Minus 3x times 2 would be minus 6x. Where we subtract. So these would cancel. Negative 2 minus negative 6 would be plus 6. So we'd have 4x. Bring down the next one, plus 8. Okay. X times what gives us 4x? 4. So 4 times x is 4x. 4 times 2 is 8. And when we subtract, we get nothing left. So that means this divides out nicely, and then this would be our solution. Let's do another example. So here we have this expression, and now we're dividing by x minus 1. Same type of thing. So we'd go x to the third minus x squared minus 2x plus 8. Now when we divide this out, x minus 1 goes in front. So our steps are the same. Again, x times what gives us x to the third? In this case, it'd be x squared. X squared times x to the third, times minus 1 would be minus x squared. So when we subtract these go away and these go away. So we have nothing left. So now, well, we have to have two pieces. So we're going to bring two things down because we have 2 out in front. So we have to have 2 down here. So now x times what gives us negative 2x? That would be negative 2. Negative 2 times x, negative 2x. Negative 2 times minus 1 would be plus 2. We're subtracting this stuff, so the x's go away. Now we have 8 minus 2, which is 6. Now x does not divide into 6, which means this is going to be our remainder. Now, how we've done division before with remainders is we just write r, but really what a remainder is we have a leftover piece. So we're saying we have x squared minus 2. Our leftover piece is 6, and what didn't divide nicely into that is x minus 1. So when we have something that doesn't divide nicely, we simply take whatever our remainder is. In this case, it's 6. And then on the bottom, we put whatever it is we are dividing by. And this would be our answer.